I want you to pay close attention. Pay close attention. We're having a very important theorem here that's going to govern our previous notion of those fractions. And it says here that a fraction or a series of these fractions, in other words, varies over the sum. So you add a bunch of numbers, right? Rational numbers. You keep adding them up. If it's finite, we don't know if it approaches a real number or it goes to infinity. All right. So it just tells us it varies over the sum. And this theorem allows us to add any parts of the fractions. So this can be 0.5, a half, pi over 2, whatever, right? This is so inclusive, but it allows us to add any number of fractions, right? Or even whole numbers too, which is 2 over 1. So that's a matter. So here's a proof right here that I came up with, and we use that proof, this technique. There are differences, and you get some number, right? S of n. As that goes to infinity, you get a sum. The distances, so you get a sum, and there you go. So this is just my way of proving it. And I'm going to show you a graph over here. Yeah, that graph. Remember, that's increasing, and if it's finite, you should get a real number. If it increases without bound, if it's 1 over some number, either it goes to 0 or infinity. If it getting toward 0, right? Or it goes to infinity. As it gets larger and larger, if it's not finite, it goes on forever, then that diverges. So this happens to be a divergent sum if p more than 1. Actually, so this, guys, I hope you enjoy this, and we'll see you next video.